In terms of New Zealand's adoption of this sort of advanced manufacturing technology, if you will, from having gone overseas and seen what other countries are doing, I do find that we are a little slower on the uptake, although I think I've heard that mentioned for other technologies as well in this digital age, but we are going to get there.
Kia ora, I'm Troy, here as CEO, and welcome to Stirring the Pot. Thanks for connecting. If you're new, here's what you can expect. We're going to be talking the tough stuff, the things that keep us metalheads up at night. There are many challenges facing our industry, and equally many opinions on how we should tackle them. Stirring the Pot provides a facilitated forum to discuss and challenge these viewpoints. So let's get to the nuts and bolts of it. Today our conversation is with Allison, who is the Application Development Engineer for Callaghan Innovations' AdLab. I recently had the chance to meet Emily and discovered what Callaghan is doing in additive manufacturing. Our conversation was so fascinating, I immediately knew we needed her on Stirring the Pot, and here she is. Emily, I think you've got such a great job. Tell us a bit more about AdLab and what your role is there.
Cool. So my role at the AdLab is as an application development engineer. The AdLab is part of Callaghan Innovation, the research and technical services there. We're part of the advanced manufacturing group, so we're one of many teams that make up this group. And our mission is to help New Zealand businesses gain maximum value from 3D printing or additive manufacturing.
Can you give us some examples where additive manufacturing touches us in our own lives, even things that we mightn't be aware of?
Definitely in places where you mightn't be aware of. One example there is in commercial aircraft. You might not know it, but parts of common newer commercial aircraft that's coming through do have additively manufactured components all throughout. Don't worry though, they have obviously gone through stringent certification and whatnot to get through. So next time you're on an aircraft you won't see it, but have a look around and take a guess what might be printed.
In our industry, a lot of our members will be familiar with injection moulding. What does the crossover between traditional types of manufacturing and additive manufacturing look like?
There's been a few cases there. One fantastic example of this is a local Wellington or Lower Hutt injection moulding company. It's called Synapco. Originally, quite a few months back, we worked with them to produce these low count shot injection moulds, moulding tools, so they could actually firstly validate the design of this component they were making. And eventually they got there, as you do. The difference is that they used additive manufacturing to produce these tools. These were printed effectively overnight, delivered the next morning, and they're able to be tested. You get about 50 to 100 shots. It really depends on material that you're injection moulding there, before the moulds actually broke. But that was enough to validate, and that's all that mattered. In the end, they went through and made their own tool. And part of what's called the safe waste wheelie bin closure tag actually has a nylon component as part of it. So that nylon's actually a printed part, and with the rubber injection moulded around it. And these closure tags are actually in use around Wellington City. So there's a contract there with Wellington City Council and also overseas in the likes of the USA.
Emily, there's been so much attention on 3D printing. What is the difference between additive manufacturing and 3D printing?
So technically they are the same thing. Although in general you'll hear 3D printing, that term thrown around a lot more by the consumer, by an individual. Additive manufacturing we tend to use more in like the industrial professional space, although the ASTM definition, they do mention additive manufacturing.
And it's got certain advantages over traditional manufacturing. What would you see as the main advantage over a more traditional process like injection moulding?
So in some cases it's often cheaper, which is always a great benefit. The other couple of things there is part consolidation. You're able to actually combine more than one part and print it as one product, whereas injection moulding you might have to go through either a couple of different steps or at a later stage have to by hand or by robot actually assemble the part. So that's one thing there. Another option is complexity of design. We've got this term called designed or designing for additive manufacturing. So we're able to produce quite complex parts that are printed all in one go. It's very, very easy for a printer to do so.
I think most people would find it surprising that it's actually cheaper. How is it cheaper, or are there just certain circumstances where it would be cheaper?
Certain circumstances, definitely. It's just another manufacturing technique. It does have its best fits, like any other manufacturing technique. So an example where 3D printing may be cheaper is in a shorter run production of smaller parts, although that is quite relative. In general, a smaller part is cheaper to print than it is than a larger part. But then, just like I was saying before, with designing for additive manufacturing, you may cut costs in other places. So part consolidation again, for example. And you might find that you'll have cost savings further down the line, for example, with cycle times as well.
And what kind of materials can be used in additive manufacturing?
Almost any material. So in New Zealand, we have several 3D printing service providers, or 3D printing bureaus, as we usually call them. And they're currently printing in a wide range of polymers and metals. And that's from PLA, ABS, polypropylene, polycarbonate. There is a nylon with a continuous carbon fibre strand through it. There's nylon PA12, nylon PA11. And the metals that we can use are the likes of aluminium alloy, cobalt chromium, stainless steels, titaniums, and Inconel. These materials are widely used from prototyping for form, fit and function testing all the way through to end-use manufacturing, and they're all available in New Zealand today.
One of the discussions that we've had previously was around this concept of digital inventory, which I find really fascinating. Can you tell us a bit more about that?
So it's just one of the many benefits of 3D printing or additive manufacturing. With that, you have you no longer have to store multiple physical parts somewhere in the world. It's all available digitally. A couple of benefits there are with the likes of they're stored digitally, so they're available anywhere, anytime. So anywhere, it's just a case of a file transfer or a download from a server. Another benefit there is in terms of mass customization as well. So you no longer have multiples of one part just sitting there waiting to be ordered or sold. You're able to tweak an existing product and send it out. It's often very, very quick.
Can you give us an example where a company has focused their business model on mass customization?
Yes, in the dental industry, so the likes of removable partial dentures. Obviously, everybody is different, and no moulds sort of fit more than one person. So you're able to 3D scan or scan your mouth in some way. The dentist will do that, and then print a mould of your mouth or removable partial denture, so you're able to ensure an accurate fit and better quality of life, I think.
Of course, our members are mainly interested in metals, so what are the developments in AM there?
Different metal powders coming through. So the process of printing in a metal is either through EBM or selective laser melting from a powdered version of that metal through to the solid product. So definitely far more metals coming through. Different variations of aluminium alloys, for example, have just been released. So that's definitely one thing there. The other part is again that design for additive manufacturing. We're able to actually use less material overall, far less waste, sort of removing a step there. And you're able to produce far lighter, far stiffer parts for your applications.
And what about on the large scale? What would you see are the emerging applications of additive manufacturing in, for example, building and construction?
Tools, jigs and fixtures is certainly something that comes to mind from my engineering background there. Just providing support. There are 3D printing technologies coming through that are there to service the heavy engineering or heavy sort of fabrication industries, which are your welding and machining centres that are more or less all in one as well. So you're able to put your workers or your employees, onto other more specific jobs where otherwise essentially a computer or a robot can take over.
One of the projects that's really captured our imagination is the project in Holland where there was a 3D printed bridge which was done using welding robots. How would you see that working in building and construction? And do you see that as an opportunity for New Zealand?
It's definitely an opportunity. I haven't personally seen it here yet, although I have seen it in Europe. And it's certainly going to be happening over in the USA as well. We've seen it a lot, these machines and whatnot being advertised for the mining industries, for heavy fabrication again, with piping, that's required in any industry there. So, yeah, they will come through. I just haven't seen them around yet, and I don't think they're quite. New Zealand's not quite ready for them yet. That's for sure.
Where would you advise a company who's looking to get involved in additive manufacturing, or even scoping up whether that's applicable for them? Where would they start?
Firstly, to go through the 3 questions of the what, why and how. Exactly what do I want to do? Is it a particular part that I'm looking at printing? Should it be printed as well is the other question you should ask yourself. Or do we have a new part in mind, a new product line in mind that, it actually possibly could be printed? Let's have a look at that. There are multiple bureaus around the country who specialise in polymers and or metals as well. They also offer design advice, and then that's also where the AdLab at Callaghan Innovation come into play. We have multiple printers on site down in Wellington, and we're spread out from Christchurch all the way through to here in Auckland. And we're here to help support. We do have those relationships with the bureaus and also industry. So we're definitely someone who you can be reached out to, even if you've got just a question, and we'll let you know.
So what scenario would it be better for a company to invest in their own 3D printing or additive manufacturing equipment versus going to a bureau?
Okay, so once you've gone through those first 3 questions, it's still definitely advisable to reach out to a bureau or the likes of us at the AdLab, where we can discuss more in detail exactly what your needs are. An example of where I'd say it's quite a good idea to actually invest in your own equipment is the likes of when you're doing, you're already quite in-house with your manufacturing lines. And you're likely to produce many of the same product as well. Is definitely where it does becomes quite a smart investment. Also, in terms of going to a bureau, very, very good for the preliminary stages. Obviously, you're going to continue learning, and you're also you've got access to these bureaus who will also provide advice.
And Where are these bureaus located? Are they easy to access? What's the additive manufacturing ecosystem looking like in New Zealand?
There's actually quite a few around New Zealand for our population size. It's quite surprising. So there is one who is just north of Auckland. They specialise in nylon and photopolymer resins using SLA technologies. There is a couple around the Auckland area. So one of those specialises in metals with EBM technology. There's another polymer specific bureau around Auckland. Bay of Plenty in Tauranga, there is a metal company there. In the Waikato, there are two bureaus also, both specialising in polymers. And then hopefully soon to be something happening down in the South Island also. At the AdLab, we are located in Wellington. However, we're not a bureau. We are here to help New Zealand businesses gain the most value from 3D printing. So we're more than likely to pass you on to a bureau once we've helped.
And what would you say are the best examples of where a New Zealand company has looked at using additive manufacturing versus a traditional method?
A good example there is probably Rocket Lab. They do get a few of their parts 3D printed, and they also use subtractive manufacturing and or moulding techniques also for their rockets. So they've definitely delved into the best of both worlds and found the right balance there.
And what about, so Rocket Lab is such a great company and it's so innovative. What about your normal manufacturing company who've been using old processes for a long time? Who could be their role model?
There is a company in the North Shore called RPM Tool and Die. Obviously, they make tooling for injection moulding, for example. They still continue to subtractively manufacture their tooling and dies and whatnot. However, they also 3D print in a miraging steel a lot of their tooling now also. So they're definitely on the up and up.
Where would you think AM is headed in the future, and how up to date are we in New Zealand?
Where we're heading, where it's headed in the future. I mean, we are essentially already there, but there's so much that's also going on. It's like any technology; it's just rapidly expanding, rapidly evolving, in every which way and direction, all the way through to material development, to machine development, to what we can actually find the correct applications for. In terms of New Zealand's adoption of this sort of advanced manufacturing technology, if you will, from having gone overseas and seen what other countries are doing, I do find that we are a little slower on the uptake, although I think I've heard that mentioned for other technologies as well in this digital age. But we are going to get there. That's certainly one of our roles at the AdLab.
And where would you see metals fitting in that direction? Where is our biggest opportunity?
There's quite a few opportunities, I think. So, I mean, aerospace is, in the development of rockets and Rocket Lab's case. Also in tooling. We don't necessarily do a lot of mass manufacturing onshore. However, we do develop. We absolutely develop a lot of dyes and whatnot there, so absolutely. More metals, you've got the medical space as well, healthcare, dental, that's already happening very much. Again, in tools, jigs and fixtures, even with parts for robots, for example, as well, automotive parts, even bicycle parts, motorbike parts, that's certainly coming through. Almost everywhere and anywhere. It's just a case of making sure that application or 3D printing is the right manufacturing technique for that application.
I was in a meeting just today, actually, and we were shown a 3D printed pen, and it looks so much better than the 3D pens that I saw, like, even just 2 years ago. And it wasn't polished, and it was produced in 5 minutes. What are the trends in consumer applications for additive manufacturing?
It's certainly come a long way in the last 10 years. Obviously, around 2008, 2009, we had sort of a boom of the consumer grade, if you will, 3D printers. So they're the desktop FDM or FFF printers. You'd liken them to the likes of a hot glue gun there. It's come a long that way, though, from printing novelty or like gimmicky trinkets all the way through to being able to reproduce household products. Say if a plastic clip broke, you're able to just print that in a polymer. More than likely, that'll do the job and that will last as well, all the way through to end use manufacturing, and that's at the home hobbyist individual level through to the professional industrial production grade environments there.
And I also have been reading around 4D printing and the trends there in the biomedical field. What are you seeing 4D printing applications looking like with current technology?
Definitely in the medical field, absolutely with implants and the like. What's actually gone on in New Zealand so far that I've seen is with the Victoria University of Wellington in the School of Design there, with 4D printing. This was with more of a creative flair, however, it's just planting that seed there. So an example there was they were printing, if you like them to undersea coral, and the likes. If you were to imagine the current floating through the coral there, and they're able to mimic that. It's very, very cool for one, but it'll also have real world applications soon. I feel keep a lookout in that medical space.
And what got you interested yourself in additive manufacturing?
I actually fell into it, if you will. I was completing my diploma in mechanical engineering, and the Polytech that I went to originally purchased a production grade stereolithography apparatus machine, which uses a photopolymer resin. We call it SLA, 3D printing for short, obviously. And I just started on that machine. I was doing some relief CAD work for the engineering school there, and then ended up just having a go on the machine. In the end, I was offered a full-time job, which was absolutely fantastic. And through that, I have built my network and knowledge bank going overseas and seeing what's out there. And then now I found myself at Callaghan Innovation, where I'm now further exposed to the likes of polymer powder 3D printing. So that's like nylon PA11 and PA12. Selective laser melting with the metal powders, and there's also a multi-jet machine there, which is another printing technology using photopolymer resin. So it's essentially just growing from there, and it's absolutely a passion.
Yeah, I can tell. It sounds really scary too, though, because it sounds really complicated. How easy was it for you to learn all that stuff?
It was easy enough. It's, having a good teacher really helped there as well. In terms of most of the designers in New Zealand, they would have been taught in their CAD programs with subtractive manufacturing or moulding sort of rules and regulations in mind. 3D printing is certainly something you've got to step out of the box with. There's a saying that complexity is free in additive manufacturing or 3D printing. Really depends on what material or what 3D printing machine or technology you're using. But certainly we have a lot more freedom in design, so we're able to produce those complex parts or consolidate many parts and just produce an assembly in one go.
And you mentioned Polytech. Is there any kind of formal training specifically for AM?
Not yet, not yet in New Zealand, although that will be showing through soon. I mean, you look at the younger generations coming through primary, intermediate and secondary school. Most, if not all, schools in New Zealand at that level have a 3D printer. So the younger generations that are our future in New Zealand are certainly going to be far better equipped from a younger age. So hopefully sooner rather than later there will be a additive manufacturing or 3D printing sort of qualification coming through.
I can definitely tell that you're passionate about AM. So where would you like to see AM adopted in New Zealand, and where do you see it going in the future?
I'd certainly like to see it adopted everywhere and anywhere, although I would like to see it adopted quite smartly as well. AM is not the only sort of futuristic, if you will, technology that is around. There are other sort of auxiliary technologies that go with that partner very, very well with 3D printing or additive manufacturing, such as the likes of 3D scanning. I'm actually hoping to get my paw injury 3D scanned soon and print a brace from that. You've also got the likes of polishing that comes through, or machining. You can also use subtractive manufacturing techniques there. In terms of a future, what's happening in the future, absolutely want to see it as part of everyone's everyday lives. It's like every other technology, it's there to make our lives easier, it's there to make our lives smarter.